And our goal today is to get a ball to bounce off of some other object. And in this case, it is a square or a rectangle. Okay. So I made my graphics project. By default, it gives me a circle. I'm going to make it smaller. I'm going to make it a radius of 20. Just follow along with me if you can. The first time you run your program, it will always be slow. And there you go. But after that, it should run pretty quick. Okay, that's a good size ball, I think, for me. And one of the things I want to do is, for that shape object, is I want to set its origin. There's a question in the lab that talks about why you would want to set the origin. The reason is this. I'm going to draw you a little picture here in paint. Okay. Whenever you draw anything in SFML, okay, there's my circle. What it actually does is it creates a rectangle around the shape and it sets an anchor point. That anchor point, when you tell the object to move, so there's my square, my bounding box, I guess, so we'll say. Okay, there's my anchor point right there. You can tell I got a very high DPI mouse here. Okay, so whenever I move my circle, it moves this point here. But I actually want my circle to be anchored right in the center. It just makes more sense for everything we're going to do. My circle has a radius of 20, so I have to set my origin 20 over and 20 down. So that is the reason that I'm going to do that line of code right here, 20, 20, like that. Okay? And I'll even leave myself a little message, anchored to center. I could choose any color I want. One way you could choose any color you want is just give it 3 RGB values, by the way. So I could go like 241, 98, and 7. That will tell it it's out of 255, so it's more red, and RG is green and blue. Less blue, more red, a little bit of green. Let's see what that looks like. You can make any color you want. You don't have to use the loaded colors. There it is. It's this weird little orange. Okay. Now, by default, when you make an object, it sets it to 0, 0. So you can see it's taken this point here and moved it all the way up to 0, 0 on my screen. And that's why the circle is kind of up in the top corner now. Let's have a look there. Yes. Okay. I'm going to just move it down maybe 100 pixels over and 100 pixels to the left or the right or something. So I'm going to go shape dot set position. And there's 2 options. I can give it this 2D vector thing, but I'm just going to give it 2 numbers. I'm going to move it over 100 and down 100 as well. Okay, so far so good. I got a little circle on the screen. Yes? Now, one of the labs talked about moving that circle around and bouncing it off the walls. I'll do that quickly in case you didn't do it, but what you basically do is you make 2 variables, one called x step, I'll set it to 5, one called y step. They're floats. Everything position wise or graphics wise in SFML is a float variable. Okay. And you get your ball or your shape, mine's just called shape, to move with an x step and a y step. Okay? If that's going too fast, I'll post this code in like 5 minutes when I'm done. Okay? So let's see what happens. It should move 5 down and 5 to the right as well. There you go. Perfect. Okay? And then all you do to get it to bounce is you just do 4 if statements. The first one is if the position of the ball is ever off the right side of the screen, so that's greater than 800, minus 20 because my radius is 20. Then I'm going to just change the x step to equal minus x step. Basically, it says if you hit the right side of the wall, switch your direction in the x. Switch your x direction. Okay. Let's put another if in there. If shape dot get position. These are all built-in functions that have been created in SFML. If the shape.y position is ever greater than 600 minus 20, because our radius is 20, then we want to flip our y direction. So y step equals minus y step. Try to convince yourself that letting x step equal minus x step or letting y step equal minus y step will switch the direction the ball is moving. Switch y direction.
So where did you set it as 5, 5? Like your x step and y step?
Right here. I set them to 5 and 5 pixels, but I do it outside of the while loop because I don't want to be making variables inside of a loop that's running 60 times a second. Okay? So let's see if this thing will bounce first. Give it a little test if it'll bounce off the right wall and the bottom wall. It should. Bounce, bounce, yes. I don't have code for the top wall or the left wall yet. I could have wrote minus 5 here, right? And minus 5 here. That would have worked as well. Let's see if it works. Yes. The only problem with that is suppose I want to speed up something later on in my project. Maybe I change x step. Well, now watch what, so it's 10. It's moving faster in the x direction. Watch what happens when it hits the wall. It slows down because I would have to go in here and change this to minus 10. So that would be a pain in the butt. It's more efficient just to say minus x step, basically telling it to switch its sign. This should be y step. Okay? Good. Now I'll just put an if statement for the other two walls. I'm not going to do else ifs just because I want them to check all of them anyways at the same time. Get position dot x if it's ever less than 20. My radius is 20. Then again, I want x step to equal minus x step. And the last one is if shape dot get position dot y is ever less than 20, that I want y step to equal minus y step, like that. Okay, so I haven't added actually a lot of code in here. I've added one command to move it and 4 if statements to bounce it, and that's it. And let's see what happens. My ball should happily bounce off all the walls.
So how did you make it move though? You didn't say
Right here. Yeah. Okay. That has to be in the loop because it has to be running 60 times a second, right? So we'll run that. Badoomp, 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 badoomp. And there's a bouncing ball. Okay, so I'll post that code somewhere here. Copy. In case yours is bugging out. Let me just post that to the Google Classroom. Pause that button there. So the other day, I gave you an assignment 3 that said create a Pong style game or something like that, right? Let's have a look at it. Yes, here it is. Create a new project called Assignment 3, a Pong style game. And it uses a circle shape for the ball. We got that. Rectangle shape for the paddles. We'll set textures. We could do that. Maybe some animation. But here is 2 functions that were written by yours truly. Okay? And they really show off the power of what a function can do. So you don't need to know what any of this code does. It's just a little bit of geometry, mostly. But I'm going to copy that code. There are 2 functions. One's called clamp. One's called collision. And I'm going to go up above my main here. and I'm going to paste those. So I got those from assignment 3. You know, later on we'll put these in a separate file so they're not cluttering our main.cpp, but for now we'll leave them there and we can use them now. There's 2 of them. Let's write the word clamp and see what happens. Yep, it lets me use it. And the other one was called collision or get collision or something. What's it called? Check collision. Let me see if I start typing check collision. Yeah, it will run that command. So before we use it, let's make a rectangle in the middle of our screen. Here we go. I'll call it rectangle shape. That's the variable type that SFML uses to draw rectangles. I'll call mine R1. Okay. Whenever I make a shape, I want to make sure that I also have a draw command for it. So I'm going to say window.draw R1. Now, will this draw my rectangle? Let's have a look. No, it didn't. The reason why is because by default, when you make a rectangle, it makes it size 0, 0. So let's go set the size of this thing. Set. Is there a set size command? Yes, there is. I can tell all the commands that are associated with it just by hitting dot. There's lots. There's like set outline color, set outline thickness, set position, rotate, set scale, set size. We want set size, not set scale. Scale will like stretch it, but if you stretch something that has 0 size, it won't do anything. Okay, so set size has this awkward thing where it doesn't take 2 numbers because it would be nice to just go 100 and 100 and have it be 100. That'd be a square. That's 100 pixels. It requires, if you look at it here, I'm just going to delete this bracket and write the bracket. It requires a variable type called vector2f. Vector2f in SFML is a 2D number that holds 2 floats. It's just like a little convenience variable that can hold 2 numbers instead of 1. So I have to write vector2f, and then in my brackets I write 100 and 100. And then that'll draw the rectangle. I'm actually going to make mine a little bigger, maybe like 200 and 200 or something like that. Let's see if it draws that. There's a nice rectangle right there.
You want your palm rectangle to be that big?
Just for now, I want to show you how the collision works. So the other thing I'll do is I'll move it to the, I'll set position. I'll kind of move it to the middle of the screen. So it's 200 by 200. So I'm going to move it to like 300, 200. And move it somewhere towards the middle. It's right in the middle, actually. That's nice. That's perfect. Okay? It does go through it right now. I've never put anything in place to test if it's hitting that rectangle. Okay? So I don't have anything in place to do that yet, but that's what we'll do next. So take a few minutes. So we've got this bouncing ball on the screen. That was 4 if statements and 1 move command. And then we also drew a rectangle. We had to set its size and set its position and also put a window.draw command for that one. So here is kind of the power of what a function can do in C++. Now, apparently this code, let's read this, okay? We're not going to read the clamp function. It's just used inside of the check collision function. So it's just kind of a convenience thing. But let me read this. It says that the check collision function, so I'll make sure that's recording, is an integer function that takes in a rectangle and a circle and returns the following. The number 3 if they hit at a corner, the number 2 if they hit on the top or bottom, the number 1 if they hit on the left or right, and the number 0 if they don't hit. It also says make sure the circle origin is set to the center. We already did that. We set our origin of our ball to the center, so we're good there. So let's see what this function could do. Now, every time I want to check a collision, I could just copy and paste all this code here, right? But then I would get pretty bloated in my main function here if I had to copy and paste this code every time I want to check collision. Now, because I have this function that just takes in a rectangle and a circle, all I have to do is write down the words check collision, and it will check if they're hitting. So it is an integer, so for now, I'm just going to put it on the screen. I'm going to write check collision. Okay? It tells me automatically what it's looking for. It's looking for a variable that's of type rectangle shape. Do I have one that's of type rectangle shape? I do. I called mine R1. So I'm going to write R1 here. And then it's looking for a circle shape too. It says name C1. You have to give it a default name, but you put in the name of your circle shape. Mine is called shape. Little shape. Okay? It's looking for your variable, not the word circle shape, not the word rectangle shape. It wants your variable. It's going to make a copy of it inside the function and look at all the details of it. So I'm going to write that on the screen, and let's see if it works. Let's see what it writes on the screen. Okay. It's writing 0. Apparently when it hits, it wrote something. Right now it's writing 0. If it hits it, it wrote a 2 or a 1. If it hits the sides, I think it writes a 1. If it hits the bottoms, it writes a 2. And if it hits the corner first, it writes a 3. So it's actually telling us when it's hitting that square. Okay? Look. See how it said 3 and then 2, 2? So it knows when it's hitting this thing now. We have information that tells us that it's hitting. Okay, so perfect. That's how the check collision function works. If this was in a separate file, check collision, we would never know what any of this code looked like, and we wouldn't care. We just know it works. We know it returns numbers when it hits. Okay? So, let's use it in an if statement. Instead of counting it, let's move our ball if it hits the rectangle. So let's go if check collision, and I just give it the names of my two shapes, my circle and my rectangle. If it ever equals 1, what does 1 mean? It hits the left or right. Okay, so if I want to bounce it left or right, my code to do that is just to change x step's direction. So I'm going to write x step equals minus x step. Okay. Then I'll check. I'm going to use an else if for this one. Is that how you do else if in C++? Yeah. If check collision, and then again I give it the names of my two variables, my rectangle and my circle. If it ever equals 2, then I want to bounce it in the y direction, because 2 means it hits the top or the bottom. If it ever hits 3, I want to bounce both directions. Check collision, R1, shape. If it ever equals 3, bounce it in both directions. Actually, I'll need brackets for this one, because you have to use brackets if you use more than one line of code in your if statement. Okay, so I'll do that. Y step equals minus y step. Okay, close my bracket up. And that's all I need to do. Otherwise, I won't do anything, right? So I'll stop writing the check collision, and let's see what happens.
Why do you make that extra else if statement and that one? Yeah.
3, because it could hit a corner.
Oh, okay.
If it hits the corner first, you can't just move it in the x direction, or it'll get stuck in the block.
Oh,
Okay. Well, let's see if it bounces. Boom. Boom. It knows when it's hitting the side, so it tells it to bounce up the side. It hit a corner there. It bounced off the. It bounced in the x and the y direction. It's kind of stuck up there. Come on. Get out of there. Go, little ball. Go. Oh.
So do we have to now make this for another rectangle now? It's like
Yeah, you'd have to do an if statement for 2 rectangles. Let's start it at a different position so that it actually can get above the rectangle. So maybe instead of setting it at 100 and 100, I'll set it at 100 and maybe like 300 or something for my circle. Will it bounce off the top as well. There we go. Cool, eh?
You guys the close this
Yeah, give me a sec here. I'm just admiring our work here. It's cool. And now if I want to, let's say, change, maybe not change, maybe change Y step to 7 or something. It will now, because I've done minus Y step in all these, it will change the angle of my ball, but it'll keep the same speed when it bounces. See that? Whoa, that's kind of a little bug. It hit the corner and bounced off in a weird way. Can't really deal with that right now, but there's a few other bugs you'll see when you make a Pong game. If you move your paddle too fast into the ball will kind of get sucked up into the paddle and rattle around in there and stuff. We can't really, we don't have a, you need physics to deal with those kinds of issues. But that is how the collision command works, okay? Basically what this collision command here does is, I'll draw another sweet picture here. Okay, don't save. Where's my circle? Right here? If you have a circle and a rectangle, it basically takes a line from the circle to the nearest point on the rectangle that it sees, and it measures the distance between them. If that line's distance is ever less than the radius of the ball, then it knows that they must be touching. So that's all that command does. Okay, like let's say I'm here, right? It'll take the nearest point on the rectangle and find it to the ball, so that's right above it. This line right now is longer than the radius of the ball, so it knows it's not touching. But if I ever get really close like this, right? Now that line, it goes to the nearest point on the rectangle and sees that it's shorter than the radius of the ball, so then it says it's touching. So that's how it works a little bit in a nutshell, but it's all coded, kind of complicated geometry stuff. You can see it's Pythagoras' theorem actually. X squared plus x squared plus y squared equals the distance squared. And you just check if it's less than the radius squared, so on and so forth. So there you go. That's how collision works, but you're going to have a more interactive program because you're going to have a paddle that moves instead of just a block in the middle of your code, okay? So I'll paste this